the refrigeration brain. We built a system that uses different refrigeration approach, and it can use just one compressor and reach temperatures minus 200 degrees Celsius. How do we do this? Well, one simple word: memory. Memory helps humans to remember more and be more productive. Memory helps computers to process more information and therefore produce more complex tasks. In a similar way, memory helps refrigerators to be more productive and produce lower refrigeration temperature. In order to do this, as I said, we need one compressor, and we add one element: the refrigeration brain. So how does this work? Well, you all know when you forget something and cannot memorize it, then you have to look it up again in order to make a decision, and therefore you waste time and energy. But when in the moment of memory loss you suddenly remember it, your brain tells you the answer, you become very, very efficient and productive. And similar way happens with the refrigeration. The refrigeration gas does not have memory. It cannot remember what was the cooling temperature when it was compressed and accelerated the last time. So now we compress the gas, and if we accelerate, we will achieve the cooling effect. But then the next time, the gas wouldn't remember this cooling effect, this refrigeration temperature, and we will have to compress it again, and then accelerate it again, and repeat this process many times. Well, this is how conventional refrigeration system works. Now we add the memory effect. We allow the refrigeration brain to remember the cooling temperature or the refrigeration temperature when the refrigeration gas is accelerated. It memorizes this temperature, and the next time we compress the gas, we use the neurons of this brain to remind the gas how to be in the state where it has low refrigeration temperature. So we compress the gas, we now accelerate this gas, the brain memorizes this negative temperature, and now we're compressing the second time. So let's say the first time the negative temperature was minus 20 degrees Celsius. Now if we accelerate the gas without the brain, we will again obtain minus 20. But the brain remembers that minus 20 was the last time. We connect it to the refrigerant gas, and neurons reminds the gas how to be minus 20 before it accelerates. So now before the acceleration gas has minus 20, now we accelerate it and obtain even lower temperature, minus 40. So now the brain memorizes minus 40, and the next time we compress it, we plug the brain again in, and the brain reminds the gas how to be in a state of minus 40 before it accelerates. And then after the acceleration, the temperature goes even lower to minus 60 degrees Celsius, and then the brain remembers it again, and then the process is repeated. We obtain minus 80, and then minus 100, and lower until we reach minus 200, and sometimes even lower. And we can do this reduction of refrigeration temperature with this approach quite fast. So from the room temperature to minus, for example, 120 degrees Celsius, we can go in 10 to 15 minutes. And while understanding the DNA of this process, we could also control the speed of refrigeration and the refrigeration temperature that we want to use in order to produce the cooling effect. And this will allow as we believe, to enable the development of superior products of the future with affordable and controllable refrigeration. And because we use just one compressor, it is 3 times cheaper. It is about 2 times more efficient, and it does not use greenhouse refrigerant gases, which sometimes can be even dangerous for operators who control this complicated conventional refrigeration system. In our case, it is the noble refrigerant gas, which has zero impact on our environment. Thank you very much for your attention. In future videos, we will talk specifically on the example of our system, how it could be useful for different players in the value chain of producing products using the refrigeration. See you later. Bye bye.